Hello. From the continuation of our topic on logarithm, and in this class we are going to handle a handful of questions basically on logarithm. So the first question on the board say, given that p squared plus q squared is equal to 11pq, where p and q are constants, show that half 1/2 open bracket log p plus log q equals I log open bracket p minus q all over 3. Then I log p plus q all over square root of 13. So we should show that we are going to use this one to show they are equal to this. So that is the question here, is for us to use this and this to show that they are what? Equal to this. So first thing we do here is to write them out. Number one here is 1/2 open bracket log p plus log q equals log open bracket p minus q all over 3. So we use this fact to establish this. So that's what we're going to look at in this class. First, if you look at this logarithm, you see there's no base here. That means they are all to base 10. Remember, in our introductory class. So if the base are not special, that means to base 10. So, and all this law, we're going to apply them. For instance, what we have here now, we're going to apply this law. Log b, okay, let's say x base b, this is n, is equal to n log xb. So we apply it here. So since this we reverse this to this, that's what we have here. We reverse it and we apply it. So this become open bracket log p plus q plus log q, everything raised to power half. So is equal to log open bracket p minus q all over 3. Then you close your brackets. So you do the operation here. Now the bases are the same and there is a multiplication sign here. So what you do here, this becomes log. We bring the log outside and we have p q. pq here means p times q all raised to power what? Half. Is that okay? Okay, in this case we equate log, or we say divide both sides by log. Divide both sides by log. So here, if we do that, this becomes log, this is p q all raised to power half divide log is equals to, here we have log open bracket p minus q all over 3 divided by log. See, log, we go with log here. So here we are left with p q all raised to power half is equals to p minus q all over 3. So what we need to do here, first of all, in order for us to clear this power, we say square both sides. We do what? Say square both sides. So if we square both sides, it means this will become p q all raised to power half times half. Okay, that is the square we are seeing here. Here we have a p minus q all over 3 all square. So we are doing it to both sides. So that this half will go with this 2, and here becomes p q is equals to, here become p minus q all square, and here we have a 3 square, and 3 square is equivalent to 9. So here we have p q is equals to, if we open this bracket, p minus q all square simply means p minus q bracket p minus q. So if we open up, here will be p square minus p q. This will multiply this, it will also multiply this. This will multiply this, and it will also multiply this. So we have a minus pq again, plus q square. So here the whole of this becomes p square minus 2pq plus q square. 3 square is 9. Okay, 3 square is what? 9. The next thing is for us to multiply both sides by 9. We want to remove this 9 as a fraction. You see, multiply both sides by 9. So multiply both sides by 9. Here we have 9 times pq is equals to 9 times p square minus 2pq plus q square all over 9. And by the time you do that, you see this 9 at the denominator here is already, eliminated from there. So here we have, it becomes the left hand side becomes 9 pq is equals to p square minus 2pq plus q square. Okay, now this is 9pq and this is minus 2pq. So we have to make sure that this one will move this way. So sometimes you say collect largest, but here I will say add, from our linear equation, add the additive inverse of minus 2pq to both sides. So the additive inverse of minus 2pq is just plus 2pq. So here we say 9pq plus 2pq is equals to p square minus 2pq plus 2pq plus q square. So 9pq plus 2pq, and that will give us 11pq. And here this one is off, and we are left with p square plus q square. So now you can see clearly that we have arrived at this p square plus q square is equal to 11pq. So that's what they asked us to show. So we should show that the whole of this is equal to if this is equal to the is having the same result as this. So we have shown it. This is q ed. So, and that is number one. The number two questions specify that we should also show that 1/2 log p plus log q equal to log p plus q all over square root of 13. It's still the same as this. So that's our next proof. Quickly, in order for us to waste time, what we have already had here, we start it from here. So we start from here. So we can quickly say that this is a log open bracket p q raised to power half is equals to log, by using the fact instead of repeating ourselves, because what we are doing here now is the same thing. So we get to this point, and this becomes log. This is p plus q all over square root of 13. So quickly, like I said here, I said you divide both sides by log, and that means you see equate a log, and we are left with this. Is that understood? All right. Okay. If we have done this, our this expression, our equation become pq all raised to the power half is equals to open bracket p plus q all over the square root of what? 13. So like we said here, we say square both sides. We do what? Square both sides. Square both sides. So square what? Both sides. Okay. Say square both sides. If we square both sides, definitely this is what we are going to see here. If we square both sides, and this become p q raised to the half times half times 2. That is half times 2 is equals to p plus q all square all over square root of 13 all square. So remember, if you look at this 13 is square root, which means 13 raised to the half times 2. So it will just give us 13. It will be 13 there. So if we come here, we now have our equation become p q is equals to p plus q all square all over what? All over 13. Because if this is square root, if you square it, it becomes 13. So what we need to do here, let's open this expression first. P plus q, two of it, p plus q. So it simply means that we are saying p is multiplying everything in this one, and q as well is also multiplying everything in the other brackets. So we are using everything in this bracket to multiply everything in this bracket. So here we have p times p become p square, p times q is pq, q times p is the same thing as pq, and q times q is q square. So all the expression become p square, pq plus pq is 2pq plus q square. Okay? Okay, if we are done with that, so we'll replace it here, and this become p q is equals to p square plus 2pq plus q square all over 13. So like we said the other time, say multiply both sides by what? We want to remove this. This is a fraction. We want to remove it. Say multiply both sides by what? By 13. Multiply both sides by what? By 13. Multiply both sides by 13. So we have 13 times pq is equals to 13 times p square plus 2pq plus q square all over 13. So that this 13 will go with this. So yes, let's clean this. Let's clean this part. Okay. Now here we have 13 pq is equal to p square plus 2pq plus q square. So now we're trying to establish the fact that we're trying to establish is this, that p square plus q square is equal to 11p. So that is the fact. So here, when this one has to do, we say add the additive the additive inverse of 2pq to both sides. So additive inverse of 2pq will be minus 2p. So if you have not done additive inverse, please just go to my YouTube channel. You'll see everything there. Okay, on linear equation, it's well explained there. So here we have 13pq minus 2pq is equal to p squared plus 2pq minus 2pq plus q squared. So if we have actually done that, you will see that this is 13pq minus 2pq, which was 11pq, and here we have p squared plus q squared. So the path for the two equation has been established. So logarithm is special, it's very important, and for it to be more exciting to us, we must acquaint ourselves with the basic laws and how they operate. So we have shown from the fact that from both paths, from the two questions written on the board, we have shown that they are what? They are this. Okay. Then I also have some few questions here to to quickly run over. That is number 2 here. It says find the value of d given that log d minus log open bracket d minus 2 is equal to log 3. Log 3. So we're going to look at that one very quickly. So that is example 2. Log d minus log open bracket d minus 2 is equal to log 3. So this is a logarithmic equation. So it's an equation, there's an equality sign. So what you do here, this is to base 10. This means log open brackets. This is d because there's a minus sign here. That means all over d minus 2 close bracket is equal to log what? Log 3. So in this case, you just divide both sides by log. So this log will go with this, and we are left with d all over d minus 2 is equal to 3. Okay. Now what do we need to do here? Here, in order for us to move fast, we just say multiply both sides by d minus 2. Multiply both sides by the reciprocal of 1 all over d minus 2. So the reciprocal of 1 all over d minus 2 is d minus 2. So this becomes d minus 2 times d all over d minus 2 is equal to 3 times d minus 2. So this d minus 2 will go with this, so we're left here with d is equal to 3 times d is 3d, 3 times minus 2 is minus 6. Okay, so our equation is now of the linear form. It's now what? Of the linear form. So we can proceed very quickly. So the equation we're having here is d minus is equal to 3d minus 6. So how do we do this? So we say add the additive inverse of d and minus 6 to both sides. So the one you use to say collect like terms, but this one add the additive inverse. Additive inverse of d is minus d. So we say d minus d. Additive inverse of plus 6 is 6. So here we have 3d minus d minus 6 plus 6. Okay. Here this is off. So here we have 6 is equals to 3d minus this one, they are off. So here we have 2d. In order for us not to waste time, our d is equals to what? Is equals to 6 divided by what? 2. And that gives 3. So you say therefore d is equals to what? Is equals to 3 in that question. Okay. Now let's take a question, example 3 here. Example 3 says evaluate log to base 5. Base 5, 3 over 8 minus, okay, plus 3 log 15 over 2 in base 5 as well, minus log base 5, 81 over 8. So this log is quite interesting. So we see that the base, you must notice the base are the same. So that means it can work. So but here you are seeing 3 here. So that means this power has to come this way before you can operate. So here we have, I will express it this way, log plus log to base 5. Here now will be 15 over 2 all raised to power 3 first minus log 81 over 8 base 5 before you now begin to apply your basis. So anytime you see if the bases are the same and you are trying to use your basic operation in the loss of logarithm, make sure that the power has to go back first in some situations. So here, since the bases are the same, we bring the log 5 out. So we observe the sign 3 over 8. This one means times 15 raised to power 3 all over 2 raised to power 3. This one divide 81 over 8 to close your brackets. So here we'll do the operation within inside, and you know in board mass, we'll have 3 over 8 times 15 raised to power 3, that means 15 times 15 times 15. This one is 2, this is 8. This one means times 8 over 81. So you change this division sign to multiplication, then you invert so here 8 will go with 8 first, and we'll be left with this. So 3 here, 1, 3 in 81 is 27. So 3 here, 5, and 3 in 27 is 9. 3 here is 5, 3 in 9 is 3, 3 here is 5, and this will go with this. Okay, now we are now left with log. We log 5 open bracket. This will give us 125 over 8. So as it is, you can express this as log 5 open bracket 5 raised to power 3 all over 2 raised to power 3, and this become log 5 open bracket. This is 5 over what? Over 2 raised to power what? 3. So this 3 can come and become log 5 over 2. So you can, there's no way you can move further here. you leave your answer in this box. Okay, this is what we can take. We also have 2 more questions left on the board. You can as well, on your own, handle them. So, until our next class, please always take off your time, help me to subscribe, and also help me to share to other groups who might be looking for things like this. Until I come your way next time, have a nice day. Take care.